In our fifth and final type of reaction, we're going to be looking at combustion reactions. Now, combustion reactions can also be referred to as oxidation reactions. However, the term oxidation we usually reserve for slower type reactions with oxygen. So when we have things that are rusting or rotting, we refer to that as oxidation. Whereas when we have huge amounts of heat and light released, when we have some sort of fuel that reacts with oxygen, we refer to that as a combustion reaction. Now, in order for something to combust, obviously it's very flammable, you need some sort of fuel. And the fuel is usually a hydrocarbon, so some sort of covalent compound that contains hydrogen and carbon in its structure. That could be methane gas, which is CH4, also carbon tetrahydride, you can refer to it as. It would be propane, like in propane barbecue tanks. It could be some sort of alcohol. So when we take a look, we refer to combustion in two different types of combustion reactions. You can have incomplete combustion or you can have complete combustion. And we distinguish between the two based on the amount of oxygen that is available. Now recall that oxygen is a diatomic molecule that is a clear, colorless, odorless gas. It's undetectable, but you need to have oxygen in order to have combustion. So you need a fuel, you need oxygen, and you need some sort of initiator, some sort of spark in order to get it to combust. So what are the products? When you have a complete combustion reaction, you have a lot of oxygen available, and you will only ever have two products. So let's take a look at this example. When we have methane and it's reacting with oxygen gas, you will always get carbon dioxide and water. If you take another fuel, like this one here, this happens to be methanol, notice that it reacts with oxygen and you also get the same two products. The only difference is that the balancing is a little bit different because we need to make sure that we conserve matter. So the same number and type of atoms are on both sides. Everything is in gas form in these particular equations because there's a huge amount of heat and light released. So when there's a lot of heat, the gas is going to vaporize. Carbon dioxide is also a gas. We know oxygen is a gas. And in this case, our fuels also happen to be gases. The fuel doesn't always have to be a gas. It can also be liquid as well. When you have incomplete combustion, however, you get two additional substances that are being made. So when we take a look at this reaction here, we have our hydrocarbon, and when it reacts with oxygen, here are the two products, carbon dioxide and water, that we saw before with complete combustion, but you also get two other products being made, carbon monoxide and solid carbon. In this burning reaction up here, because we see evidence of black soot, that is your carbon, this indicates that there's not a lot of oxygen and that this is an incomplete combustion. The reason incomplete combustion is so dangerous is because of this deadly carbon monoxide gas. Carbon monoxide gas is, again, colorless, odorless, tasteless, yet it's deadly to your body. What ends up happening when I put you in a room with carbon monoxide and with oxygen, your blood has a higher affinity for carbon monoxide. What that means is that your hemoglobin, which carries oxygen throughout your entire body, likes to bind to it more than oxygen. So this is why we all have carbon monoxide detectors in our homes. Here is a demonstration of a combustion reaction. It's a very common chemistry demonstration called the whoosh bottle. I just want to show you the demo here.
The whoosh bottle is a very popular demonstration, and there are a couple different ways you can do it. The approach that I'll be showing you involves the use of 70% isopropyl alcohol. Kathleen will be using 100% rubbing alcohol or isopropyl alcohol, and Steve will be using 95% ethanol. What we hope to show you is that concentration does make a difference in terms of how fast things will burn. Let's load the whoosh bottles and see who wins. If there is a danger in this demonstration, it would be not using enough alcohol. because it's important to make sure that you have more than enough alcohol so that oxygen is the limiting factor. Because we want a burn, not an explosion. The meter stick with the wooden splint will allow us to be a greater distance away from the bottle. Left hand on. Whoop. Okay. Ready, Steve-O?
Ready.
And let's light them. As you can see, there was a slight difference in the rate of a reaction.
As we can see in that demo, we had different types of alcohol, but you did get a combustion reaction. And because there was no evidence of any black carbon soot, we can assume that those were complete combustions. And we can also see in this demo over here, the same thing in slow-mo, you can see that we get a nice blue flame, which is indicative of complete combustion reactions. So now I'm going to take you through a lesson sheet that will help us balance complete and incomplete combustion.